see you. My name is Lee Seok-woo, to the professor in Tripoli. So I'm going to cover your tutorial in week 1 and week 3. So today we're going to have the first tutorial class about the optics. So today we have 5 questions. So are you ready? All right. So question number 1. A laser beam is incident at an angle of 30 degrees from the vertical of the solution of the cone syrup in water. If the beam is refracted to 19.24 degrees from the vertical, what is the index of the refraction of the syrup solution? Okay, so now we have the incident angle of the laser beam and refracted angle. And you want to find the index of the refraction. So there are 3 variables, 2 are known. And now you can use this Snell's law for the refraction. N1 times sine theta 1. Theta 1 is the incident angle of the incident beam. Equals to N2. N2 is the refractive index of the cone syrup in this case. And times sine theta 2. Theta 2 is the refractive angle. Alright, so you can use this simple formula. Then, what do you know? Okay, N1 is air, which is 1. And theta 1, incident angle is 30 degrees. And the refracted angle, theta 2 is 19.24 degrees. And N2 is unknown. So from this equation, you can find the refractive index of the syrup solution. N2 is 1.52. Okay, so actually the fun fact is this refractive index of the cone syrup solution is 1.52, is very close to refractive index of the glass, as you can see here. So once you put this glass stick into the cone syrup solution, then actually it is almost invisible because there's no any reflected light. Alright, I just finished question number 1, so if you don't want to miss it, feel free to take a picture of this screen. Alright, as you can see here, so we use the Snell's law. So for the remaining 4 questions, yes, this is the only formula you're going to use. So I hope you remember that. Next, light with a wavelength of the 700 nanometer is incident on the face of the fused quartz prism, as you can see here. So we have a prism here, and this light of the 700 nanometer is incident on this side. The refractive index of the prism is 1.42 at 700 nanometer. So this is the very important condition because depending on the wavelength, the refractive index is always changing. So, to be accurate in the question, so we need to give such condition. So at an angle of the 75 degree, this light is incident at an angle of 75. This path to the normal to this surface. Okay, so this is the beam, and this is the normal direction for this surface of the prism. Then this theta 1 is 75. the apex angle of the prism is 60 degree, as you can see here. Then calculate these three. Angle of the reflection at this first interface. So this is the interface, and theta 1 is 75. Then you want to calculate this theta 2, the reflected angle. Second, angle of incidence at the second interface. So this is the another interface, another face of the prism. Then this is the direction of the propagating beam. And this is the incident beam at this interface, and this is the reflective light. Okay, so this theta 3 is angle of the incidence, and theta 4 is the reflected angle. So in the second question, you want to calculate theta 3. And then lastly, you will calculate angle of the reflection at the second interface, which is theta 4. Alright? Then, for the first question, angle of the reflection at this first interface, yes, it is very simple. You're going to use Snell's law. And 1 times sine theta 1 equals n2 sine theta 2. And theta 1 is 75 degree, and 1 is 1, and 2, the refractive index of prism is 1.46. Then, among these 4 variables, we know 3, and remaining one is theta 2. This is what we want to calculate. So just do the math using the calculator. Then theta 2 is 41.4 degree. So this is the 41.4. And now, next question. So this theta 2 is 41.4 degree. Then you want to define theta 3. So this is the matter of the geometry of the triangle. Okay, then let's draw this triangle. As you can see here, the apex is 60 degree. And another 2 angles are alpha and beta. Okay, then what is the angle of alpha? Do you have any idea? So we already, yes, very good. So this is the right angle, and we know the angle theta 2. So you can define alpha. Okay, so theta 2 plus alpha is 90. And what is beta? Theta 3 plus beta is 90 degree as well, as you can see here. Then, what is the sum of the inner angle of the triangle? This is 180 degree. Okay, then let's use these 3 conditions. So, add these 2. Then, theta 2 plus theta 3 plus alpha plus beta equals 180. Right? Then, you can define alpha plus beta from that. Then apply this, then you can derive 60 minus theta 2 minus theta 3 equals 0. Then we know the value of theta 2, which is 41.4. So you can calculate theta 3, 18.6. Alright, now we know the angle of the incidence of this beam. Theta 3 here. Then let's use Snell's law again. So, N1, in this case, N1 is 1.46 for this prism. Theta 3 is 18.6. This is the angle of incidence. Then, outside, N2 is air. So, N2 is 1.0. Then, eventually, you can calculate theta 4. 27.8 degree. Very easy, right? Okay, so I hope you can be more confident of this physics class. Okay, then Do you have any question? Alright, then let's move on. So, by the way, let me double check. So you already took the lecture of the optics part yesterday, right? Okay, great. Thank you. Okay, question 3. Determine the maximum angle theta for which the light lays incident on the end of the pipe shown in figure here. A subject to total internal reflection along the wall of the pipe. Assume that the pipe has an index of reflection of the 1.36 and the outside medium is air. So reflective index of the air is 1.0. Alright, so this is about the total internal reflection. Okay, so how can you define this critical angle of the total internal reflection? Alright, so now we have interface right here, and we have the vertical line. And this is air, and n equals 1.0, and this is glass. Alright. Then now, let's imagine that you have incident beam which is perpendicular this interface. Then what happens? Is there any reflection? No. It will follow this vertical line. And then I tilted this angle a little bit, like this. Then what happens? It will be refracted. Okay, then let's increase the angle a little bit more. Then it will be tilted more. Then eventually you reach it to certain angle, and then it will propagate along this interface. So the reflective angle is 90 degrees. Okay, then let's apply Snell's law.